Welcome back. This is Geometry, Unit 6, Section 6.2, Properties of Parallelograms. This is video 3 of 4. I'm going to take some time to start to apply what we learned, specifically about angles and about diagonals on a parallelogram. So we have to find the missing angles, the missing variables inside of these parallelograms. Again, when you see that word parallelogram, we can instantly hold true all the properties of parallelograms as well as the definition of parallelograms, which should help us come up with measures inside of these drawings. So on the first parallelogram, there's lots of different equations you could write. You could write the opposite angles are equal to each other, so you could write 3x equals y. Kind of a downfall with writing that because you have two variables, so it's going to be hard to solve for just one. But you could also use the idea of consecutive angles. So 3y and y are consecutive angles inside of a parallelogram, and consecutive angles means they're on a transversal, they're in between two parallel lines, therefore they are same side interiors, and we know those are supplementary. So y plus 3y is equivalent to 180 degrees. We solve for y, so we have 4y is equals 180 degrees. I divide both sides by 4. Let's do some mental math here. So 18 divided by 4. 4 goes into that at most 4 times. So 4 times 4 would be 16. So I'd have 20 units left over. I'd have a 2 left over, but in the tens location. And then 20 divided by 4 would give me 5. So the y value is going to be 45. So that is 45 degrees, as well as this being whatever 3 times 45 is. And then in the end, we can also solve for what 3x is equivalent to. We know that opposite angles inside of a parallelogram are congruent. Therefore, 45, which is y, should be equal to 3x. And we solve for x, and we get x is 15. So knowing that the opposite angles are congruent and consecutive angles are supplementary can lead you to writing supplementary equations or equivalent equations. Okay, let's move to the second parallelogram. Now we just have angles. So this is where your ability to see parallel lines being cut by a transversal is pretty imperative. So the angle that 28 degrees is measured is alternate interior with the y variable. So y is also going to be 28 degrees. Let's draw 2 more parallel lines here. Remember, opposite sides inside of a parallelogram are parallel. So that means that 71 and z are also a pair of alternate interior angles. So z is going to be 71 degrees. So we have 28 degrees down here, 71 degrees. We should be able to figure out the third angle measure over here, that measure of angle x. And you can do this a couple different ways. You could combine, erase here. Could combine these two angle measures, 71 and 28, if you want to, and know that they should be supplementary with x. That's one version of the question. Or you could use your idea of the sum of the interior angles of a triangle is always 180. So x plus 71 plus this was 28 plus 28 would equal 180. As long as you're writing some type of an equation, that is true. So I'm going to stick with this equation. We'll solve for this. I get x equals 70 plus 20 is 90. 1 plus 8 is 9, so this would be plus 99 would equal 180. So I'm going to take away 99 from both sides. So x is going to equal, let's see, 180 minus 100 would be 80, but I subtracted one extra number. So it really would be 81. And now we have our solution. We have x is equivalent to 81, we have z is equivalent to 71, and we have y is equivalent to 28. Traveling back up, we have one more question, so multiple angles inside of here. So again, we're going to use our knowledge of parallelograms as well as our knowledge of alternate interior angles, vertical angles, you name it, we can apply it here. So let's start with alternate interior angles again. That's where we started our last question. Parallel lines cut by a transversal, so 26 and y are alternate interior angles. And then looking on, we have, looks like I have supplementary angles right here. These two angles right here, when I combine them, I should get 180 degrees. It's a good time to point out, this is not the next, not everybody has to take this step that I'm taking. Everybody can actually come up with the measures of these angles in whatever format they want to, as long as there's logic to it, as long as they're following the justifications we've used. Okay, so to find this angle right here, I would think 180 minus 62. 180 minus 62. Let's see, the 180 minus the 60 would give me 120, and then minus 2 more would give me 118 degrees. So this angle measure right here in the middle would be 118 degrees. We have vertical angles right here, so this measure is 118 degrees. And lots of things we could do to find this last measure, x over here. Oops, I forgot to write down that z. Z is 118 degrees. And then inside of this last triangle right here, I have 2 out of the 3 measures. So I should be able to come up with the third measure. Or, going back a long ways, just saw this, the 62 is an exterior angle. That should be equal to the sum of the 2 remote interiors. So that's another way to come up with it. So really, 62 minus 26 should produce this angle measure right here, x. Or x plus 118 plus 26 would all equal 180. Either one of those would work. I'm going to use the triangle exterior angle theorem. So we have 62 minus 26. I'll do some old school subtraction here. Borrow a tens to fill in the ones. 2 ones turns into 12 ones. We'll subtract. We get 6. And then 5 minus 2 gives me 3. So that angle measure x would be equal to 36. Again, the whole premise of all of these questions is that you have the ability to apply what's true about parallelograms, which are the properties, as well as all the other intel we've discussed in class with parallel lines, vertical angles, and anything else that applies inside of the scenario.